Fact or fiction? To infinity or not?
This is the part where we blow up! Not today! Ah! Hey, Buzz! You're flying!
This isn't flying, this is falling with style.
To infinity and beyond! Buzz! We missed the truck!
We're not aiming for the truck.
We've all watched Toy Story as a kid, and we're amazed by how Buzz and Woody glided to Andy's car. But is it really possible for Buzz and Woody to glide as they did in the movie? Let's approach this problem from a fluid mechanics standpoint and find out. We want to start off by analyzing the glide itself. To do that, we will model Buzz and Woody's glide after the flying squirrel problem we've done in class. We will consider gliding to mean that the toys are descending at a constant rate. That is, they have zero acceleration in the y direction. By using these equations, we see that drag and lift force depend on the angle of attack, density of fluid, fluid velocity, and surface area. Here, we've measured the height, weight, and width of the toys and assumed ideal lift and drag coefficients, as well as the density of the fluid. For our purposes, that fluid is air at 290 Kelvin. To get the velocity component, which we denote a capital U, we used a program called Tracker, which, as the name suggests, can track a moving point in a video. We looked only at the part of the clip where Buzz and Woody's y acceleration is approximately 0, and averaged the overall velocity data to get u, which we then put in terms of the lift and drag forces. It turns out that these terms sum to 0, which means the x velocity is constant. We can then put the horizontal velocity in terms of the total velocity and the angle of attack. Next, we perform a force balance in the vertical direction. We first assume that the net vertical force, which we denote as m times y double prime, is 0. After a bit of algebra, we are left with an equation that lets us solve for the angle of attack necessary for Buzz and Woody to glide. Once we plug in all the other parameters, we get that alpha is undefined. There is no angle of attack that would allow Buzz and Woody to glide. Just to be sure, we attempted this flight path in real life. Since there is no possible angle of attack given their horizontal velocity, we calculated the minimum velocity Buzz and Woody would need to have for any flight path to be possible. We set the angle of attack equal to the limiting case of 90 degrees, meaning the toys would travel vertically, never catching up to the truck. After some quick algebra, we found out that they would have to be moving at a speed of 85.68 meters per second, which is around 191 miles per hour. We have concluded that this scene is fiction. There is no angle of attack that would allow the toys to glide as they did in the movie. To bring this a step further, we took our project beyond Earth and looked for a possible flight path. First, we investigated the moon. We took into account the different gravitational acceleration on the moon and the lack of atmosphere. However, it still is not possible for Buzz and Woody to glide, as the angle of attack would still be undefined. To go even farther, we looked at one of Saturn's moons, Enceladus, with an atmosphere consisting of water vapor and a diameter 1/7 that of our moon. We discovered that it is plausible for Buzz and Woody to fall with style, with an angle of attack of about 70 degrees. Tune in next century for Fact or Fiction. Did Rose really need to let Jack go? Special thanks to Sunny and Brian for making this all possible.